Hello kiddos. Today we're going to be talking about trapezoids. This is lesson 8-4. Thank y'all for tuning in. So trapezoids, they have a couple of properties that I want y'all to write down. The first property is that a trapezoid is a quad, meaning four, and let me make sure I spell this right, quad R-I lateral, meaning it has quad four, lateral meaning lines, so it's got four lines. So a trapezoid has four lines, but it's a special type of quadrilateral. We've got three examples right here. The other property of a trapezoid is that two of the lines are parallel. Two of the lines are parallel, so two of the sides are parallel. Okay, so in fact, instead of lines, just make a little note here. Say sides too. Okay, let's zoom in just a little bit here. There we go. Okay, so we've got three examples. Notice on the top here, this side and that side are parallel. These two sides are not. On this example, once again, these two sides are parallel. These two sides are not. And then on this last example, these two sides are parallel, which means that when I say parallel, it means that if I extend this line and this line out forever and ever, in either direction, they'll never cross. These lines, even though I know that in this right here, the two lines are slanting in, and this line's going straight up and down, but this line is not, so it's not parallel. Eventually these lines will cross if you just trace it up high enough. Okay, so let's talk about how we're going to name these. We're going to name the parallel lines base 1 and base 2. Okay, so we could put, for abbreviation, we could put B1 and B2. So B1, B2. The sides that are not parallel, we're going to call those legs. Right, so we've got legs on either side. Those are the legs. So this example right here, this would be legs, and these are the legs right here. Okay, now we also are going to have to determine the height. So the way we do that is we go from the bottom of the base, we hike up to the top, and we're at that top vertex right there. Alright, and we're just going to drop that rock straight down, and when we see that right angle sign right there, that's the height. So that's the height, and we can do that from either side. That's also the height. So we'll abbreviate that as H. So H, woo, drop the rock. H for height. That's the height. Okay, right here, that's the height. Now in this case, the leg is the height because the leg creates the right angle here, so that could also be, that leg could be the height as well. Okay, we're going to talk about area, and for area I have this little example right here, and I don't know if y'all remember, but on Friday we looked at the area of a shape that looked like this, and we call this a parallelogram. And we said, well, okay, if we cut off the edge right here and just reattach it to the other side, it actually ends up being the same shape as a rectangle, so we can just multiply the base times the height right here, and that will give us the actual area. Well, we kind of have a similar situation, the trapezoid. Okay, and here's what I want you to sketch on your paper. So I've got this one trapezoid here, but if I take an identical trapezoid and I flip it over, I get a shape like that. Okay, Now if I then cut off this edge like we did on the parallelogram, let's see. There we are. And let's see if I can get this to come off. There we go. Okay. So I've got something like this. And then I just attach that side right there. I end up with something that looks very much like a rectangle. Isn't that cool? So if I'm going to find the area of one trapezoid, if I can add the lower base, the top base, oh, and by the way, go up here for properties and just add for number 3. I forgot to mention this. Add a third one in there, and then say that the parallel lines are different lengths. Parallel lines, different lengths. Okay, sorry about that. Parallel lines are different lengths. Okay, so right here, if I add this base and this base, so 6 centimeters to 4 centimeters, I get a box that is 10 centimeters, or a rectangle that is 10 centimeters. Oops. And the height is 3 centimeters. See, the height is 3, so over here the height's still got to be 3 centimeters. So that would give me an area of, if I'm doing the rectangle, of 10 centimeters times 3 centimeters, which equals 30 centimeters squared. Okay, now if I want to find the area of just one trapezoid, I can just take away the one that I put on there originally, and now I'm left with half. So if I just take this 30 centimeters squared that I found and I divide it by 2, I get 15 centimeters squared. Okay, so what I'm finding out is I can just put this picture back up here. Okay, I can just take both bases, add them together to get 10, and then multiply by the height, and then divide by 2, and I can find the area of any trapezoid. So, come over here, and the area for the trapezoid, just fill this in, it's height. Remember, we did the height, which was 3 right here, and we multiplied it. And in parentheses, we had base 1, which was 6, and we added the second base, which is 4 centimeters. Well, we'll put base 2. And that gave us the area of the whole rectangle. And then we just divided it by 2. So the area of a trapezoid is height times base 1 plus base 2 divided by 2. Okay. Now we have a challenge problem down here, and I'm going to let you try that problem tonight for homework, and then bring it back tomorrow and we'll go over it in class. Okay. Thank you for your time, and have a wonderful night, and I'll see you tomorrow. We'll talk more about trapezoids then. Bye.